Times are changing for DD. The founders of DD are retiring, and perhaps it's time that the DD headed off in a different direction. The DD industry is about 50 years old, and I see the people responsible for the first generation setting the LinkedIn employment status to retired at home almost daily. I, for one, have a foot in the camp, but reporting writing is different than having a full-time job because I can control the time commitment. We've seen many serial entrepreneurs who had created several successful companies over time. They have performed the invaluable service to the industry. Unfortunately, their time is up. Long ago, Vicious realized that EDA companies that do not produce the massive gain compared to other software or internet companies. Funding almost dried up, except for companies championed by people with a track record that reduced risks and thus did not demand the same level of return, but it also significantly reduced the number of people who stood a chance of getting a startup going. Even then, they often had a pivot a new times before they gained traction. In a recent roundtable, I was accused of being stuck in the last century when I suggested that AI agent would benefit from better interfaces and standards associated with the data that comes out of the ED tools. This was perceived as being a minor inconvenience and a more importantly sequential thinking. This may be true, but my motivation for a suggestion was that AI is forced to work on unreliable data that potentially contains unnecessary interpretation, that any solution is hoped from the start. Data cleanness is wanted, and that the start at the source is getting rid of the ambiguity has got to be a step in the right direction if the reliable results are to be expected. The irony is that people who made the accusation have been rattling around the industry for almost as long as I have. I know I am somewhat set in my ways. That is why it is always refreshing to hear from people who had not been doing for 50 years and who are ready to question every aspect of what we do. One of the panelists said, I love the idea because it means there are people thinking like an engineer should. How refreshing. While great strides can be made by new development, there is a lot to be gained from stepping back and correcting the mistakes that have been there for a long time. Many years ago, I was given responsibility for acquired tools that had an enormous bug list, many of which has been there for a long time. My manager asked when those who were to be fixed, and I was going to prioritize them. So my first step was to take a look at our code base and for some coding disciplines and rewrite some of the fundamental pieces of code which I found errors or might lead to performance issues. It took 6 months. At the end of it, we ran all the bug cases, and 60% of them were gone. We also saw a 30% performance increase in the whole product. The point that if you have only ever look forward without sometimes looking in rearview mirror, you sometimes do not get the whole picture. I miss constant feed of information that comes from startup companies. They are working on few or exciting problems that are advancing state of the art as they acquired. The information stream stops dead in its tracks. I can understand why it quickly becomes wrapped in a bigger story or product that tends to be shared with the primary customers when the media are suddenly left out in the crowd. Apart from we can extract specific pieces of information deemed suitable for general public. It's not only the companies that are despairing, but the people as well. Startups see as a much broader industry knowledge than just their current company. In many cases, they export a large part of the design and verification flow and cherry pick the biggest problem areas for their next startup. They continue to keep their finger on the pulse of the rest of the industry, because as soon as they are quiet, they are probably looking forward to their next startup. That makes them highly valuable information sources because they need visibility for company and not just a small advancement in their current tool. Legatable their numbers are dwelling, and I fully frame I have seen the last tip from many of them. But did those startups contribute their linear think of the whole industry? Is it a time for new people with fresh ideas to find the direction of future? Both of the big independent EDA companies have been a change at the tops. Lots of fresh engineers are entering their ranks, hopefully with their youthful spirit and determined make a stage to make a difference to think like engineers. I hope those take over from the old guard allows them to do that. Traditionally, EDA has been about creating data that is used by humans to make a decision. This applies to this design at all levels of reflection, verification, implementation. So the era is about how to extract knowledge from data with much automation as possible, allowing humans to make a decision about the what to build rather than how build something. Time will be tell effective this transition will well the best draw the lines between the automation and human expertise. The next is the price of fear. Lusk and fail to go hand in hand within the semiconductor industry. Finding ways to reduce them is to balance against time and cost. In my last blog, I talked about how pain is important when making prediction in the semiconductor industry. Pain is related to time to market to risk, and the flip side of risk is fear. Fear is one of the main drivers for a large number of EDA tools, such as those whose related verification. The fear is taping out of a chip, then the waiting for what seems like an eternity to get the first chips back, only to find that they don't work. The precious time to market is lost whilst diagnosing the problem, fixing it, re-verifying it, probably running many other tests again, then getting back in the queue to have another batch of chips made. The more advanced the mode, the more potential issues we must be aware of. Many of those still may not be fully understood. If we start to add new issues associated with 2.5D and 3D packaging technology, then the number of new problems rises quickly. Advanced nodes use more masks, which are expensive, and fab capacity for those is at a premium. It often is reported that mask sets run in the millions of dollars. There may be very conservative number of many designs, maybe the costs are low for mature nodes, making the less of an issue. So in fact we got back to the enough years. It's not uncommon for a companies to report 3 or 4 or 4 respins. I know of a company that often had several spins to get it right. Could it have this verification cycle that caught up the problem? Should we have tried hire a new specialist who understood an issue we thought wasn't important, or been lucky about it in the past? Are we properly prepared for all the uncertainty related to a new manufacturing process? These are all real fears that every companies have been must balance against the cost. While it is often said that the role of Silicon Valley to be make mistakes fast and improve quickly, this is not an area in which that applies. It is the purpose is to reduce the cost associated with the design and manufacture, which could come from optimization or automation, or and to reduce the fear of the failure. Each tool has that automate to analyze and verify to reduce the risk of failure will escape. In addition, most companies will insert additional logic into devices to reduce the risk of total failure, adding chicken switches if adding chicken switches and replacing extra unused circuit in the chip that can be deployed to a metal change, speeding up the cycle time when problems are found. Other chips rely on a software to work around many problems that are found, even if the slight reduction in functionality or performance. How much of a failure is real? There is messaging put out by some EDA companies that is misleading. For example, verification complexity is said to be related to the scale of the number of states in the design. This is blatantly wrong because it's assumed that every state is somehow dependent on every other state. If there are subsystems operate independently, then there are no such expansion in the problem space. If a system is duplicated, there may be independencies on the nearest two neighbors, but this can be collapsed into set problems that do not have to be verified against each separate duplicated block. What is generally true is that as design size increases, the number of the potential places where bugs may hide increases, then requires a full understanding about how system is meant to be operate. Knowing the intended use cases can significantly reduce the total state space that needs to be verified. A corollary, a corollary to this is related coverage. Given the way the coverage is defined today, it's never possible to say what 100% complete means. In theory, it's possible to do this or using other ways, but for some reason that industry prefers the existing method, which is based on proxies for coverage. While this was a suitable method when the first defined for communication devices, it's awkward at best and incomprehensible for many of today's systems. It also has no concept for concurrency, sequence, and other important aspects that need to be verified. A new system was proposed for portable stimulus that was much better, but it's not clear how much of the made it into standard. Risk management is a complex process, and it's where the best managers stand out from the best. They have to be defined properties and acceptance levels, decide when it's worth buying a tool, hiring people, or taking other risk reduction strategies. It's possible that may help find the right balance, and in some cases may improve the efficiency of existing tools. However, this is not in the best interest of the EDA companies unless the development of those AI tools generate enough income to offset sales of tools lost because they are more efficient. EDA companies have economic reasons to go down this path. These business models do not align. This could be an interesting development for the future. It can do the work harder or work smarter maxim. Buying more tools may increase the number of cycles verification you can do and thus reduce fair, but using existing tools more effectively may be the better option. EDA has to find ways to sell reduction and do not sell do and just not sell tools. The first step along the path is stop spreading unnecessary fear. Next article is shift left is the tip of iceberg. Transformative changes underway for semiconductor design and EDA. New language models and applications will need to be created. Shift left is evolving from a buzzword into a much broader shift in the design methodology and EDA tooling, and it's still eagerly in. So there is widespread agreement that it will be transformative. The semiconductor industry has gone through many changes over the past 2 decades. Some are obvious, but others happen because of convergence of multiple factors that require systematic change in the process itself, which is the case study today. On the surface, shift left may look around minor change involving optimizing strategies or the introduction of a new in metric, but this is a fundamental move from an initial semiconductor perspective to the start of the system age of design. What is perhaps even more surprising is that a push for change is coming from all sides of the existing flow. This is not the first time industry has faced such challenges. Shame the vast institutional fog of war has caused us to forget about those lessons. Jay Rob North, Group Director for Strategy and New Ventures and Cadence, we've experienced this multiple times. We've seen faced with a scope with that broader than tools we have based on physics and phenomena, all that aren't perfectly captured by tool you have. We've faced deadlines and are too aggressive to be able to do a perfect job. People who have succeeded in those epics are ones who are honest about what can they simulate, what can they estimate, and how it will have impact the people up and downstream of them. The change encompassed many areas, some of which are itemized below. Change in the optimization focus, optimization strategy have shifted from a simple power performance and area PPA metric to system level metric, such as performance per watt. If you go back into 1990s and 2000s, the roadmap was very clear, said Chris Off, Director of Advanced Technology Programs at Intel Foundry. Just make things smaller, make things faster, make things cheaper. We are seeing the spread wide out into a variety of different uh, uh, avenues. PPA optimization is just one thing you do, but there's a lot of other things, including thermal or frequency per watt, that optimize for. I don't think the story is fully written on how to do that. The 3D IDs are cheaper assembled than just fabricated pieces of IP. They are changing many aspects of development flow. 3D ID is changing the market and industry, said Lee Hisu, segment leader for high-speed design at Keysight. PPA is now involved in multiple disciplines. You are not vertically structured any longer. You are incorporating a lot of different blocks into a system design. So how do you optimize that from a system perspective? What are the languages you are going to use to talk with those different die or different functional blocks? It places interesting market demand for chiplets or heterogeneous integration for system level. We need to optimize your system performance by utilizing different die and optimize the entire packaging performance. How those dies are arranged, assembled, they're validated, and tested remains a significant challenging. However, some of that work can be done ahead of time through pre-assembled, pre-integrated chiplet. The workload and software is somewhat well differentiated happening, said Christopher Lump, Senior Director of Automotive and ARM. So we will still sell IP products, but we are now assembling them into large subsystems. Increased independence or naturally become connected to each other as we get closer to the limits imposed by physics. The goal in the design closure is to optimize across multiple variables based on certain conditions or inputs provided by the user, said Manoj Chakko, Senior Director of Import Product Management and Synopsys. In addition to PPA, there is R for reliability or robustness. This started when we had to consider IR voltage drop, which was impacting performance. Tactics to mitigate that were developed. Then we see variability of the devices and device behavior changing based on the neighbor's usage context, and that is impacting on the performance of design and impacting power. Domain-specific design. Gone are the days of general-purpose design. In many industries, the bespoke silicon is the only way to achieve the necessary design characteristics. You've got to form a general computing board workload-specific applications as Intel's oath. Everybody has different that may have need to push the technology. PPA is a component, but there's a lot of things to PPA doesn't cover. This is especially evident in automotive design. If you think about a car, it's a real system modeling challenge. And Jean-Marie Bruno, Vice President and General Manager for Hardware Assisted Verification and Siemens EDA. They have different sampling rates, different clocks, different accuracy of the models. How do they do things to each other? Each industry integration challenging, which is we have the digital twins. They can give you a visual representation of the N and level device of the system. This is incredible synchronization and integration challenge, and it is a very heavy compute platform environment. So you have to make a decision about which software will work with the specific hardware. So the system design. This system is no longer just the hardware. Lavi Pudar, senior leaders and advisor for semiconductor industry at AWS, noted that Volvo reportedly has about 120 ECUs and 100 billion lines of the source code and 3 million functions and 30 million places in source code. We are seeing the shift left using software virtual twins. Podler said this includes virtual hardware in the loop and it requires you to test early and test often. Software is now an integral part of the hardware design, but the development schedules often are different for hardware and software. The software is always missing, and when doing the analytics of the system and the hardware, said Ahmed Amjad, solution architect for the Cybertronic System Engineering Initiative at Siemens EDA. You build a system. If you don't what the software will run the system, the whole equation will change. Hardware, system, and software are three pieces that we need to put together early enough in the analysis that will impact how future system engineering is done. What hasn't changed is the way we have to approach the problem. The key things about optimization is that as you go through the flow, your degrees of different freedom increase, said Marcus Swinen, director of product marketing and ANSYS. In the beginning, you have many degrees of freedom, and your potential optimization is much higher as you go further down the flow. Your degrees of the freedom reduce, the potential goes down. Engineers like to be divide and conquer. We cannot do everything at the same time, said Kisite Lee. We know that the order in which things need to be worked out. Of course, not everything is equally critical for every single application or use case. Some designs are more focused on the system performance, otherwise are more focused on power. Every engineer or system architect had their own charter. Go in and optimize. We are entering a new era where it's not completely stabilized or mature. The holistic optimization. The what is achieved over at a given step in the development flow is limited by productive uncertainty. When you make a change in your design, let's just say power, there is a signal, but there is also noise, which means there is uncertainty, said Ansis Swinen. The actual the power could be a bit higher or lower because you don't have the wires, you don't perform the exact synthesis. There's noise level in your information, and given the amount of uncertainty you have at a given stage, you can only optimize down to the noise level, and that's beyond that any information could be spurious. You are wasting your time. You're just randomly generating numbers. You have no idea if you're lower or higher. You are limited by the noise band, and once you hit the noise band, it's time to move on to the next step because there's no more optimization that makes this step even relative. Where you start the analysis higher the independent optimization course, one you need is good software solution that can stimulate the entire system you are gonna have. Say off that you can optimize each of the components. You end up with a lot of very customized software that stimulates a variety of these things. It stimulates them summers, it stimulates frequency or something like that. That's a big opportunity for software can give you a better answer to the iron. So as to the best way to optimize the technology. But it's essential to understand the accuracy of the models or information being used. A simple way to describe each garbage in garbage out, says Lee. How good the model that represent each of the in the heterogeneous integration. If your model is not accurate enough, you're building an optimization top of it, then you're optimized based on the garbage. While simulation is technologies that super powerful, they need to be addressed or integrated the right way so the accuracy is preserved. If you don't have those technologies or models, and you're going to develop something based on the wrong input data. In the past, the industry has developed the abstraction that have preserved necessary accuracy while latency computation time at the front of it. You don't have a metric, said Swinen. You've proxies, for example, power density is a good proxy for thermal. For timing at the RT level, you use your wire loaded models based on fan-out. As you go into placement, you use your Manhattan distance. Then you go to the routing and the length. The router is actually looking at the timing. The placer is not looking at the timing. Each step has each proxy, which gets better and better, and it's only when the routing is done, then you finally have an RC motor. That's not a proxy anymore. Now you have actual stimulative delay of the wire. This means you must constantly assess what is possible both in terms of accuracy and effort over computer power. What help do you need to improve the accuracy of your process? You may need some creativity to try the strategy that didn't work in the past, said Cadence North. Maybe you didn't have the computer horsepower to do all the simulation you needed. And today you might. When you're talking about PP optimization strategy, and most recently we saw this with power. You didn't see have enough horsepower to integrate vectors into the design optimize phase. Well, now the algorithms are better. The estimation techniques are more accurate. The stimulus horsepower is better. You can start integrating some data that in the past you just estimated and now you can actually measure it. Better estimation allows for more optimization and automation. Design a network on a chip NOC requires a analysis based on physics design, said Andy Nightingale's vice president of project management and marketing at Artemis. When you control aspects of the physics placement coupled with the many analysis tools, we can build an explore tool that lets you traffic profiles so you can push tons of the transactions. I will continue the next time. Thank you for your time. See you next time.